The topic of solving polynomials. This topic only has one objective, and that is to find all solutions, roots, or zeros of a given polynomial. Keep in mind that sometimes these roots will be x-intercepts, but sometimes they will not be x-intercepts. At times they might be imaginary solutions, and again, those don't cross the x-axis, so they wouldn't be x-intercepts. So, the first step in this process, and again, please be aware that this process to find all solutions of polynomials of degree 4 and up, usually degree 4 and up, will call upon the knowledge you've gained from the fundamental theorem of algebra, the remainder theorem of algebra, and the factor theorem of algebra. So, again, the fundamental theorem of algebra states that the highest power, or the degree that exists in the polynomial, states the number of roots, or tells us the number of roots, and then mainly from the remainder theorem and factor theorem, we're going to be using synthetic division as a step in this process. So you should by now have mastered those types of things to move into this objective in this topic. So to begin this process, and I've listed this question here, I'm going to call upon my knowledge of the fundamental theorem of algebra, and my first step always is how many solutions exist, and that's why I asked that there in the above function, how many solutions exist. So p of x, I look for the highest power. It's x to the fourth right here. And so x to the fourth tells me that I'm looking for 4 solutions. And so I'm going to show you the first step, and that is to use the calculator to graph this. Right here, I've given you the picture of what your graph will look like. And so the question is then, why do only 2 show up on its graph? And to me, I know that there's going to be 4 solutions, but only 2 show up on the graph of the x-intercepts. So I know 2 are real solutions and they're x-intercepts. And so to answer that question, the other 2 must be imaginary because they still exist. And I know from prior modules that imaginary solutions don't show up on the graph. They're not pictured. And so 4 total, 2 are real, 2 are imaginary. And so in order to find all of them, these are the steps that I'm going to take, and I've listed out this for you to utilize as well. And so the first step, it says right here, in this example, it says find all the roots of p of x equals x to the fourth plus x cubed plus 2x squared plus 4x minus 8. I know I'm looking for 4 solutions based off of the fundamental theorem of algebra, and so I need to go through the process of finding all 4. The first solutions I'm going to find, because they're real, I'm going to use the calculator to find the real roots. That will always be the second step technically. The first is to consider how many solutions exist. So the second step is to use the calculator to find the real roots. So I'm going to pull up my calculator, and here it is. When you have your calculator up, the first thing you're going to do is go into y equals. You're going to input the function, the polynomial function that you see here, x to the fourth plus x cubed plus 2x squared plus 4x minus 8, into the y1 area of your calculator. So why don't you, I've already done that if you can see, so why don't you pause the video and input it into your calculator as well and make sure it looks exactly like mine before we move on. So at this point you should have paused the video and inputted the function into your calculator. Then after you have it into y equals, you're going to hit graph. Now it's going to graph the picture of this function, and if you notice, it hits on the x-axis twice. So that's going to give me 2 real solutions. Solutions exist at x equals -2 right here, and then x equals +1. So I can write those right here, x equals -2 and 1. So I am done with my first step. I have used my calculator to find the real roots. I saw where it crossed the x-axis and I wrote it down right here. So I'm done with the first step. The second step then is to use synthetic division to break it down until factorable. So again, this calls upon knowledge from either the remainder theorem or factor theorem, where we synthetically divide the solutions out of the given polynomial function until it's more reasonable or more manageable and something we can work with to solve, whether it's a quadratic trinomial or something of that nature, where you're familiar solving in other strategies. So, in order to synthetically divide, it doesn't matter which one I do first. I'm going to use -2. I'm going to draw my division box. I'm going to put the coefficients up, so 1, 1, Then I'm looking at the powers. It goes from 4 to 3 to 2 to 1, so there's no space holders needed. And it's 1 and 1, and then the next number is 2, and then 4, and finally negative 8. Synthetically divide negative 2 out of this. I'm going to drop down the 1, multiply to the inside, outside, add to the inside. Negative 2 times 1 is a negative 2. 1 plus a negative 2 is a negative 1. Negative 2 times negative 1 is a positive 2. 2 plus 2 is 4. Negative 2 times 4 is a negative 8. 4 plus a negative 8 is a negative 4. And then finally, negative 2 times negative 4 is a positive 8. At this point, draw my remainder box. I have a remainder of 0. And I know that's true, and I know that x equals negative 2 is the solution of the function. I found that via the calculator, and I also found it via synthetic division. Now, I've already synthetically divided this negative 2. Now I have to synthetically divide 1 out of there. So I draw one more synthetic division box. I put 1 up here now. And I drop down the next number, which is 1 in this case. So I multiply to the outside, add to the inside. 1 times 1 is 1. Negative 1 plus 1 is 0. 1 times 0 is 0. 4 plus 0 is 4. And 1 times 4 is a positive 4. Draw my remainder box. Negative 4 plus 4 is 0. At this point, I am done. Now, to rewrite my new polynomial after I've synthetically divided out negative 2 and 1. So if you remember that process again, I'm going to use these numbers, 1, 0, and 4. But again, I'm going to now add my variables back into the mix. And remember, we started out with the highest power of 4, and every time you synthetically divide a solution out of the polynomial, you lose a power. So we've synthetically divided twice, so 4 minus 2 is now x squared instead of x to the 4th. And I just add in my x's as sequentially down to the lowest power of 1. In this case, I only had to add 1. And if you notice, it's 0x to the 1. So my linear x term doesn't exist. So I rewrite it in polynomial form. I'm going to get x squared plus 4. I don't have to put plus 0x because it doesn't exist because it's 0. There's none of them. So at this point, it says, and I've finished step 2. I've synthetically divided and rewrote my new polynomial down here, x squared plus 4. My third step is to factor and solve. So there's a couple different ways. This calls upon knowledge from Module 3. You can either MACAB T-chart it if it's a quadratic trinomial. In this case, this is not a quadratic trinomial. You could take the greatest common factor, but in this case, there is no greatest common factor because you need an A and a B term for that. So the two other solutions are solved by taking the square root or using the quadratic formula. Again, the quadratic formula always works. So if you want to use that and identify your A, B, and C and use the formula to find the two other solutions, then go ahead and do it. That's great. Otherwise, in this case, solving by taking the square root is going to be simpler. And again, I know that I can solve by taking the square root in this case because there is no B term. I'm going to write the A is 1, B doesn't exist, and the C is 4. So whenever this situation occurs, I can solve by taking the square root. Or more specifically, I can just solve by isolating x, getting it by itself. So when I solve anything, I have to set it equal to 0, and I'm going to rewrite it over here. X squared plus 4. I have to set it equal to 0, and then I have to solve for x, get it by itself. So the first step is to subtract 4. Subtract 4. So then I have x squared equals negative 4. And then if you remember, to get rid of the power of 2, I have to take the square root. Square root. Now, these cancel out. I'm left with x equals, remember, the positive and the negative. Whenever you take the square root of something, you need the positive and the negative version. And then I have to break down, for now, let's say it's still negative 4. So I have to break down this radical. The first step in working with radicals, if you remember, is to check it to see if it's a perfect square. And in this case, it is. I can show that. This breaks down to 2 and 2. I can circle my pairs, and so a pair of 2's comes out. So I have x equals plus or minus 2. And then if you notice as well, I'm taking the square root of a negative. I can't do that. It doesn't exist, so I have to show that I'm entering into the realm of imaginary numbers, and so I have plus or minus 2i. So, I have found two more solutions. I can rewrite it as 2i and negative 2i. And so those are two solutions, and then I already found two solutions from my calculator up here. And so to finalize this process, and again, this step right here won't always look the same. It just depends on what you're left with for a polynomial. Sometimes you can solve by taking the square root, sometimes you can solve by factoring with the MathApp T-chart. Sometimes you'll have to use the quadratic formula. It just depends on what you get there. And so, in this case, I solved by taking the square root, and I found two more solutions. So to finalize this and to make sure I know that you did everything you needed to be successful at this objective, you have to put all of the solutions in one location. So I'm going to do that right here where I began. And so, the solutions, again, to check your work, the fundamental theorem of algebra states the highest power equals the number of roots, so it's the power of 4, and I have 1, 2, 3, 4 solutions. And I said at the beginning of the video, 2 are real because they hit the x-axis, and that means that 2 had to be imaginary. In this case, that's exactly it. We have negative 2, 1, 2i, and negative 2i. So right here, I am done. So, go ahead and try this problem on your own. First step is to use the calculator to find the real roots. Second step is to synthetically divide and get it into a factorable polynomial, rewrite it as the new polynomial. And then the third and final step is to factor and solve with one of the methods I've discussed. So go ahead and pause the video and try all of that on your own. And then when you're done, unpause the video and check your work with mine. So at this point, you should have paused the video and tried the you do problem on your own. So the first step is to enter the polynomial into your graphing calculator into y equals. As you can see, I've done that in my calculator. Alright, so I've entered x to the fourth minus 4x squared minus 45. Then I'm going to hit graph. And this gives me a picture. So I need to check where it crosses the x-axis, and at this point, or at this situation, it crosses the x-axis twice. It hits at x equals negative 3 and x equals positive 3. Use the calculator to find the real solutions. The first step then is just to write those out. X equals negative 3 and 3, and please identify that you got those from the calculator. Then, the second step is to synthetically divide. So as you can see, I've synthetically divided both of my real solutions out. Please check your work with mine. And then that synthetic division should lead you to a quadratic that is solvable either by factoring or taking the square root or using a quadratic formula. And as you can see, I got x squared plus 5 for my final part, or step 2. And then from there, I did step 3, which I solved it. And I solved it with the same method I did in the I do example that I showed you just a little bit ago in this video. So I got x by itself, and then I took the square root, so technically it's solving by taking the square root. And that gave me two more solutions. I had the square root of a negative 5, and again, you can't take the square root of a negative, so I have plus and minus I root 5. So I have the positive version of I root 5 and the negative version of I root 5. And again, please, please, please finish out these types of problems with writing all of the solutions in one place so that I can see that you've done it correctly. And if you notice, the highest power was 4, and I have 1, 2, 3, 4 solutions. And that needs a radical 5 in there. So if you didn't get negative 3, 3, I root 5 and negative I root 5 for your solutions after you've checked your work, please raise your hand so I can come discuss the problem with you.